All right, everybody. It's time for another episode of the Michael Shermer Show. I'm your host, as usual, Michael Shermer. My guest today is Alan Stern. He is a planetary scientist, a flown commercial astronaut. Oh, we got to talk about that. Space program executive, aerospace consultant, and an author. He was last on the show with his co-author, David Grinspoon, for their book, Chasing New Horizons, Inside the Epic First Mission to Pluto. So we'll get an update on that. Stern's first space flight, a research and training mission, occurred in 2023. NASA has selected him to be the first researcher NASA funded to fly to space as a crew member aboard a commercial suborbital space mission. This second space mission is expected to fly in 2026. In 2018, he was appointed to the 6-year term on the U.S. National Science Board. In 2022, he took part in a deep-sea expedition to explore the RMS Titanic in a submersible. Thank God you weren't on that other one. And his research is focused on studies of our solar system's Kuiper Belt. I think that's how that's pronounced. And that's the Oort cloud. Yeah. Comets, the satellites of the outer planets, the Pluto system, and the search for evidence of solar systems around other stars. He has also worked on spacecraft rendezvous theory, whatever that is. Oh, I know what that is. You're trying to rendezvous spacecraft. Yeah. That's a good idea. Terrestrial polar mesospheric clouds, galactic astrophysics, and studies of tenuous satellite atmospheres, including the atmosphere of the moon. I didn't think the moon had an atmosphere. Okay, we have much to talk about here. Last point, though, 2001, he's led NASA's $900 million New Horizons mission to explore Pluto, and he also manages a $5 billion a year Science Mission Directorate with the government with 93 separate flight missions and a program of over 3,000 research grants. Wow, that's quite the biography there, Alan. How's it going? Nice to see you again.
Good to see you, Michael. That last part, I'm not doing it now. That was something.
Oh, you're done with that. Oh, okay. Oh, yeah. That was okay. That's
2007.
Yeah, but still, it's interesting. I mean, how does it work? The government funds science and research, and then somebody has to allocate where those grants go, and that was your job for a while.
Well, it's not just grants; it's the missions. You know, NASA Science, which leads the world and has for a long time. We outstrip everybody. At the time I was running it, there were a little bit north of 90 different space missions, either in development or already flying, about half and half. And some of them were to be as simple as weather satellites, and others were probes to the outer planets, and then Hubble Space Telescope, Mars rovers, lots and lots of others.
Yeah.
Those are the big projects. The grants are really for data analysis. They're small projects.
Yeah. And in this, in your bio mentioning, a private rocket launch you were on. So there's government and there's private. There's Elon, SpaceX, and Jeff Bezos, Blue Horizon, and so on. Or Blue Origin. Yeah, Blue Origin. But NASA by far and away is much larger in terms of budgets, right?
Say your question again. You were broken up. I'm sorry.
Oh, sorry. Yeah. I must be pixelating here or something. Yeah. So, but how would you compare the budgets of NASA public versus private space companies like SpaceX and Jeff Bezos' company?
Well, there was an interesting study I read. I believe it came out last year from McKinsey, the consulting firm. They did an analysis of the worldwide space economy. It across the world, all the countries of the earth and all the private sector stuff is $600 billion a year. Wow. Space expenditures 2023. Now the NASA budget is about $25 billion. Compare those two numbers. NASA and other government programs are really dwarfed by commercial space industry these days.
Oh, wow. Oh, I had no idea. That's amazing.
Most people don't. No, and that's a good thing. Because, we can't just pay for it out of taxpayer dollars. That's great for developing new technology and making us a world leader. But otherwise, you have a self-licking ice cream cone. We have to have an economy in space. That's what commercial space is really all about.
And so what other countries have private and commercial, or commercial and public?
Well, something north of 50 countries now have space agencies. CIA says there's 194 nations on Earth, if I remember correctly.
Yeah.
So was that about a quarter of them have space agencies? So many of them very small compared to NASA. But some, like the European Space Agency and JAXA in Japan, and of course what the Chinese are doing, very large public space agencies of their countries. And then commercial activities, they happen all around the world. They have for a long time because of communication satellites. They got
Mm.
started when we were all children, 50 years ago or more. But really, commercial space is now many things besides just commercial communication satellites. There are private space stations that are being built as a space tourism industry. There's a lot of Earth observations. There are a lot of new kinds of communications like these Starlink satellites and the Kuiper constellation that Amazon's putting up and things like that. Blue Origin's involved in, and it's just multiplying. And it is blown my mind how quickly it's gone from commercial space being the vast minority and people very skeptical. Only governments could do these things to the fact that commercial space completely dominates not just the dollars, but the innovation. And I like to say it's because of that, we're living now in the early 21st century where Star Trek really begins and where people will look back in a couple of centuries to our time and say, that was the inflection point. That's when it took off.
Wow, that's amazing. I had no idea. But I thought even private companies like SpaceX were so heavily subsidized by government contracts.
Well, they certainly, in many cases, private companies have federal government contracts. But a lot of what they do has nothing to do with that.
Mm.
For example, SpaceX is launching, most of its satellites are commercial satellite launches. I say most of its satellites. I meant to say most of its satellite launches are for the commercial space industry, including their own Starlink,
Mm.
which of course is selling terminals to private individuals, like you may have one, people all around the world. And of course, a lot of government agencies around the world use it too. So it's really blossoming into not just the old World War II kind of model of aerospace, in which the aerospace companies were government contractors and did very little else except build airplanes. But on the space side, it was almost all government work. And now that is an important but shrinking section of the pie chart. And that's what I think is so important in terms of a shift in the 21st century.
Yeah, that's amazing. Wow. Yeah, I live in Santa Barbara, so we see the Vandenberg launches quite frequently. I must be every 2 weeks or so. There's a rocket going up,
Yeah.
and
I've seen a couple out of Vandenberg, and they're very impressive, aren't they? Even from Santa Barbara or LA.
unbelievable. And I drove up once to watch one as close as you could get, and yeah, it was just amazing. And then the rocket comes back down and lands. Just astonishing that what
It's like
they've been able
sci-fi.
to do. Yeah, it's like
It's
sci-fi.
not. Sounds
I
like
know
sci-fi.
it's science nonfiction.
Yeah, this is
Yeah, I
the real
remember
deal.
seeing the Starlink, the string of Starlinks satellites before they spread out and dispersed, go right over my house. It must have been like one orbit around or something. If
And
you
that's
didn't know what
impressive,
you
isn't
were
it?
seeing, you'd think, well, that's like a UFO.
Except it's an identified flying
Yeah,
object.
that's right. It's an IFO. Yeah. Well, a lot of the UFO, UAP sightings, as they're called, are just people mistaking Starlink satellites. Yeah. So, all right. Well, what's it like to go into space? What did you do? I don't know anything about this.
Well, I flew on a very brief suborbital mission, means it goes up and down in less than an orbit, like Alan Shepard and Gus Grissom did in the 1960s as the first American astronauts, and like the X-15 pilots. I flew on Virgin Galactic. They're the flight provider. I flew on their Mission 5 and conducted some research for my company, which paid for the flight, and also did some training towards a second flight that I'll conduct with NASA in 2026 or maybe early 2027. Schedules haven't quite firmed up yet.
How much do they charge for an astronaut to go up?
Well,
Are
it
you allowed to
depends.
say?
I can tell you, when they first started offering tickets 20 years ago, before they designed or built the system, it was a couple $100,000. And of course, inflation is, if you correct it for inflation, that would be what, 1.5 or 2 times that today. But they actually charge still more because there's so much demand. It's just supply and demand. And then if you fly with experiments, they charge, of course, for the experiments as well. So there are additional charges. And how it actually works out in the end depends very much on the details of what you're doing. So if I told you it cost me X to fly my experiment, that wouldn't mean that your experiment would cost the same. It might cost less.
I
It
see.
might
I
cost
see.
more.
So
But
how long
but
was the entire flight?
the entire flight was about an hour, and it was the
Oh,
most amazing experience I have ever had professionally.
really?
I
Really?
can't I can't it I can't even almost put it into words, how exhilarating it was to ride that rocket. And I'm a guy that flew F-18s, for 5 years doing, airborne astronomy and jet fighters, and that has been to the South Pole, and like you said, I dived to Titanic and done a lot of really interesting things, and, the exhilaration of a rocket ride to space and, seeing the Earth from space and how vast the continent of North America is with your own eyes, and then going through reentry and a glider landing. It was just, it's addictive. I wanna do it as often as I can.
Oh my God, that sounds great. Where did you launch from?
Launched from, Spaceport America, which is, a base in southern New Mexico. Actually very close to where rocketry got started by Robert Goddard 100
Right,
years ago, southern New Mexico.
right. And then you glided back. How do you do that in a rocket?
Well, it's so the system that Virgin Galactic has is a two-stage system like the old X-15 that
Oh,
flew in the
I know what
19
you mean.
so
Yes,
there's a
right.
carrier aircraft that carries the little spacecraft up to 50,000 feet, and then after checkouts, they do a 10, 9, 8 countdown and release the latches. The spaceship falls for a moment or two and then ignites the rocket engine. And once it goes supersonic, they go vertical and you fly up to space after about a 60-second powered boost to Mach 3. And then you're weightless, going over the top. The sky is black. The earth is curved. Everything looks like a little scale model, but just spectacular. You can see half the continent out the window. And then after a few minutes in space, you come back to a reentry and 5 Gs of deceleration. And then as you go subsonic, they become a glider like the old space shuttle and target for the runway and glide down onto the runway and use speed brakes to come to a certain velocity at the moment of touchdown, and then actual brakes to bring it to a stop on the runway. It's it's
Wow.
it's it's a ball. You should do it.
I want to do it. I'd
And
be
it's
happy
not
with
that
just the vomit
physically,
comet.
it is not that much exertion. And I'll tell you something else, that Vomit Comet, which I've flown in dozens of times, the zero-G airplane that
Yeah.
astronauts train on and researchers like me use to do microgravity experiments, that makes a lot of people sick because they do it over and over and over on a given day.
Mm.
It's not so bad now, but back in the old days, people like I flew NASA flights where they would fly 60 zero-G parabolas in a single afternoon. There
Oh
was a
wow.
lot of what we call roadkill, people getting, motion sickness and even losing their lunch. Today on the commercial zero-G airplanes, almost no one gets sick. In fact, I flew my wife and kids in 2010, and even my daughter, who as a child was prone to motion sickness, she didn't get sick. And
Wow.
on space flights, these suborbital flights, you just do one parabola. You're just up there, and no one has ever gotten sick on one of them, to my knowledge. No one. You do fine. You love it.
Yeah, I'll say. What experiment did you do?
Well, um, what I did was a training experiment getting ready for this NASA flight to
Mm.
reduce the risk to get some practice at an astronomical experiment that we're going to be doing. And at the same time, I wore a biomedical harness, actually two different biomedical harnesses that were recording physiological data on me as not a tourist, but as a person who was going there to get work done. And
Mm.
what's your blood pressure? What's your respiration rate? What's your uh, heart rate as a function of time during the high G's on ascent, during the microgravity, and then during the high G's on reentry?
5G sounds like a lot.
It's not bad.
No?
It's really
Huh.
not bad. It's a kick in the pants. It's a lot of fun. I trained at 7 and 8 G's, and uh, it's a little bit of training. You get used to it. It's not hard.
What
It's
would it
stressful. I mean,
what
it's a
what
workout,
yeah.
but
How
it's not.
high
But it's not bad. It's
how
not
high
bad. I
did
would
your heart
fly.
rate get?
Oh, well, I was pretty excited. I think it was going pitter patter pretty fast, but that's
That's
because I was
funny.
a happy guy.
Yeah.
A lot of times I would go to the centrifuge, this company called NASTAR, this commercial centrifuge in Pennsylvania. And we would train and do 4 or 5 launch simulations at 1.5 times what you actually fly. Like you train for a race, you overtrain, you run
Mm-hmm.
faster or harder or longer. Well, we would do 5 launches in a single morning. And, this was just one launch, and it wasn't overtraining. It was actually at launch acceleration. It's pretty
Right.
straightforward. And,
Yeah.
William Shatner did it at 90 years old.
Yeah.
And he came back and he had a ball. I'm nowhere
Yeah.
near 90, right? I'm not going to be 90 until the middle of this century. And you know what? It was so much fun, and it was so moving as a human being to see the planet. And after all that high altitude flying and everything, nothing compares to space flight. It's just
What's
exhilarating.
what is that called? The overlook effect or something like that? Or
Overview, right?
overview? Yeah.
Yeah, yeah. And a
Changes
lot of
your
people,
perspective.
it does change your perspective. You see it for yourself. I remember, uh, I fly for business very often. You get used to looking out the window and you take it all for granted. You forget when you were a child how exciting it was to get on an airplane. And I was
Mhm.
on an airplane. I remember the flight. I was flying on an airplane from Houston to San Antonio, Texas. Very short flight, but the passenger next to me was a 7-year-old boy who'd never been on an airplane.
Mm.
When we got above the clouds, that kid went nuts. He'd never seen anything like that. And between that and the acceleration on takeoff, he was just having the time of his life. And, I remember when I first started flying very high performance jets as a crew member, it was like that again for me. And then for space flight, yet again, I don't see how you could ever get tired of it.
Yeah. Yeah. I've never flown in a F-18 jet. That must also be pretty exhilarating.
They're very powerful machines. Even more powerful, I flew F-104s a number of times for G training. These are old 1960s, Century series fighters. They were very dangerous in the original days, and they got the nickname uh, Widowmakers.
Oh
Uh,
God.
but they are hot rods. We would take off, and as soon as we get level and tuck up the gear, right, we'd hit the afterburner and pull the stick straight up, vertical climb, 6.5 Gs to 30,000 feet. And then the pilot would cut the engine and push the stick over. We'd go weightless. And then you dive back down into the pattern and go around. And as soon as you get back over the runway, here we go again. Afterburner, stick up, you're on your back going up to 30,000 feet. And by the time an hour went by and you'd done 5 or 6 times around the pattern,
Hmm.
you're just wringing wet. Like in the movie,
Mhm.
Top Gun, you see them in the locker room and they're all sweating from the G's. It's
Yeah.
really like that.
Is it what's the height of the suborbital? That's over 100,000 feet, right?
Oh, much higher. We were
Yeah.
flying up more than 50 miles high, about 300,000 feet.
Oh my God. Oh, right.
So when I
But
say the mountains look like scale models, they look
yeah.
way down there.
So, but what's the definition of space? What, there's like some level.
Well, there's 3 definitions of space. And one of them is NASA calls anybody an astronaut that's been above 50 miles.
Okay.
And there's a second one called the von Karman line, which is 62 point something miles. It's 100 kilometers. And some people prefer that definition. And then there's the one that I use, which is, you know what? If you are weightless, the sky is black and the earth is curved,
You're in space.
it sure looks like a space flight, like a movie you saw from Apollo or, the space shuttle. I think you're in space at that point. We were up
Yeah.
at 300,000 feet at apogee. And that's above the 50-mile line that NASA gives astronaut wings for.
Yeah. Yeah. Wow. 300,000. So 10 times higher than a commercial airliner.
So imagine the airliners, the little contrails. If you imagine just standing over the Earth, and eye level is the height of this top of the space flight, the airliners are flying around your ankles, way down there,
Right.
right?
Right.
It's pretty
Yeah.
impressive.
Well, I think a lot of the early UFO sightings by commercial airline pilots were of probably the U-2 spy plane or the SR-71 Blackbird that was going just super fast way up in the sky, because that's what they described. But they were classified, so even the pilots probably didn't know about it.
Well, probably not. And I think people see a lot of things in the sky that they can't identify what it is. And it may be as simple as balloons sometimes. The thing about UFOs is that there's never really been a scientific method applied to it.
Mm-hmm.
When we have a phenomenology we don't understand in astrophysics, we start applying all these scientific methods to look at them at every possible wavelength in every way we possibly can, and to get statistics on how they behave and how much energy they put out and how fast they go and where they are on the sky, and do they correlate with galaxies or stars, or nobody's ever done that with UFOs, made a really systematic study. It's always these chance sightings, which is not a very scientific technique.
Mm-hmm.
So we really, I think we're always going to have this craziness around what are they, and is there, something behind it, until we apply the scientific method, and that's going to cost some money. Somebody's got to, whether it's a philanthropist or a foundation, or whether it's a government agency, or whether it's who knows. Until you apply the scientific method, it's always going to be accidental sightings and storms, and
Yeah.
you're never really going to understand it, in my view.
Well, that's what Avi Loeb's trying to do with the Galileo Project is, get funding and build these little observatories to place around the United States and actually just film everything. 99.9% of it will just be birds and planes and stuff like that. But every once in a while, an anomaly may pop out. Here's what Scott Kelly, you probably know Scott Kelly, astronaut and pilot, which I cite in my chapter in my next book on UFOs and UAPs. When people say, yeah, but he was a pilot, so I really trust what he says he saw, right? So here's what Scott Kelly says. In my experience of flying over 15,000 hours in 30-something years in airplanes and in space, the environment that we fly in is very conducive to optical illusions. So I get why these pilots would look at that go fast video and think it's going really, really fast. I remember one time I was flying off Virginia Beach military operating area, and my RIO, radar intercept officer, who sits in the back of the Tomcat, was convinced we flew by a UFO. I didn't see it, so we turned around to go look at it, and it turns out it was a Bart Simpson balloon. And then he says, my brother, Mark Kelly, former NASA astronaut, now also a U.S. Senator, shared a story with me about an experience he had years ago when he was the commander of the STS-124. They're getting ready to close the payload bay doors of the space shuttle, and they see something in the payload bay, and they thought it was a tool, maybe a bolt. They couldn't quite figure it out. And they were potentially going to have to go and do a spacewalk to retrieve it. But before they did that, my brother grabbed the camera, and they took a picture of it. And when they blew up the picture, they realized that it's not a bolt or a tool in the payload bay. It's the International Space Station 80 miles away.
There's a lot of things like that. I remember one of the Apollo missions, I think it was Apollo 17, one of the TV views showed what looked like the hull of an orange spacecraft lying in the distance from the landing site. But when they blew it up and looked at it carefully, it turned out to be this little orange flag that they had left with a grenade charge they would later use to make a seismic explosion as a scientific experiment. And it was just this flag from a funny angle in the distance that just happened to look like the hull of a spacecraft lying on the surface. And it was a simple explanation once they figured it out.
Most of the sightings have those kinds of explanations. Even the pro-UFO people who think that we're being visited by aliens, they admit 95% of all the sightings have terrestrial normal explanations. They're hanging on to that 5% anomalies, and, I don't know, what do you do with that? Maybe you can't explain everything.
Yeah, well, in astronomy, we often find these outliers, the things that are rare, and then we'll find a whole bunch of them if we look hard enough, and then we'll eventually figure out, that's how things like quasars got discovered in the 1960s. Right. And so there may be some real phenomenology about it, and my bet is that it's not alien civilizations that have come to look at the Earth, but it's got a simpler natural explanation, or it may be a combination of things. Some of them might be super secret vehicles that different agencies or other governments fly. Who knows? I don't know.
Well, but you're way more connected than I am to the government. Is it possible that they have the equivalent of a SR-70 Wood Blackbird now that we won't know about until 10 or 20 years from now, and that's what people are seeing?
I am not expert in this, and I haven't been on the defense side of space since I was right out of college, my first job. And so that was a long time ago. I really don't know what their capabilities are any more than anybody else who reads a newspaper.
Or drones. There's a lot of stuff that we may just not know about. Well, so back to astronomical anomalies. There's, I mentioned Avi Loeb. He's all over this 3I Atlas object that's come into our solar system from somewhere. And it's in a peculiar orbital pathway, he says. Well, not him, but it seems to be passing by several planets, Saturn, Jupiter, Mars, and so on. It looks like the kind of thing NASA would have programmed the Voyager spacecraft to, hit as many planets as you can in one shot.
I beg to differ here.
Okay.
I know a fair amount about this. I'm not one of the world's experts, but I used to be in this very topic. And I published scientific papers that were, peer reviewed about this phenomena. And the way it works is this, and bear with me for just a minute
go for it.
To give you the background.
Yeah, go for it.
It's really interesting. When we now know from NASA satellites primarily that stars are really good at making planets. Almost every star that we look at with the right capability, we see planets have formed or they're forming now, if it's a young star. So planets are ubiquitous. And when planetary systems form, you get to real big objects, the ones we call planets, their gravitational muscle clears out the regions between the orbits of the planets, and it just starts flinging stuff. That's not a technical term, but in effect, that's what happens. And just like the Voyager spacecraft intentionally would get flung, or like my New Horizons project, me and 2,500 of my best friends built and flew to Pluto, got flung by the planet Jupiter to get to Pluto faster. All these inanimate objects get thrown all around the solar system, and many of them get thrown out of the solar system altogether into interstellar space. And so for a long time, ever since the 60s and 70s, scientific papers were predicting that there was just an uncountable number of these interstellar comets, and that as our solar system moves through space, they're passing by. Sort of like in the fall when you see like a cottonwood tree, just seeds going by you in the wind. And we've recently, in the last less than 10 years, developed the capability to find these needles in the haystack. 3I Atlas is one of them. Now, 3I Atlas is the third one we found, and we're probably going to find a lot more now that we know how to do it, which is great because these are samples from other solar systems, so they're scientifically valuable. But 3I Atlas has not gone close to any planets. It's going past the orbits of planets, but it's not even millions of miles. It's tens of millions or hundreds of millions of miles from when you hear it's passing by Mars. It's passing by Mars at large distance. It's passing by Jupiter at large distance. It's just flying through our solar system as an inanimate object. It's close enough for us to study, and we're going to learn a lot from it. But it's not like a Voyager spacecraft being targeted to flyby after flyby.
I see.
Close reconnaissance observations. And, when you read it in the press, the language is sometimes not as precise as a scientist would use it. But I'm telling you that when you read that it's passing by all these different planets, it's passing very far from them, not right up close, the way we target flybys.
Yeah, Avi just posted something on his blog. It's 29 million kilometers from Mars at the closest it'll get. That's a long ways.
29 million kilometers is roughly 20 million miles.
Yeah.
That is close to 100 times as far from Mars as the moon is from the Earth.
Right.
It's crazy far away.
Yeah. What about the outgassing? It doesn't look like a comet, or is that changing now?
So far it does. It looks like a comet, a big comet, because, and by the way, the reason it's big is because the only ones we can detect are the biggest ones. Later, when our capabilities are better, we'll detect smaller ones. But it has a lot of the same gases that we see come out of comets in our solar system. And some of its properties look a lot like a comet. But as we study more and more of these, hopefully we'll learn about the variety that different solar systems make in throwing these objects out into interstellar space, just like our solar system did long ago. And so it's a new area of astronomy because we didn't have this capability until 2017 or so.
That's amazing. I figured it had to be something like this. So like the discovery of quasars is just a new natural object we didn't know about, or some variation of that. So if you have enough of them, some of them are going to have weird trajectories. Avi had it calculated at like 2% probability it would have this particular orbital trajectory into our solar system. But I can't help but thinking if you have like 100 different ways it can come in, it's got to be in one of them.
It's got to be one of them, right? And we know pretty accurately that there's something like 100 billion stars in the Milky Way. Give or take a factor of a couple, but approximately 100 billion stars. And if solar systems are common, as we think we see from actual data, then every solar system has ejected somewhere between a billion and a trillion of these interstellar objects. So the galaxy is populated with something between a billion times 100 billion to a trillion times 100 billion of these things.
God.
They're everywhere.
Right. So it's really just a matter of detection.
Yeah. And of course, space is enormously big. That's why we call it space. And they're very spread out from one another. But still, the numbers are, not to make a pun, but they're astronomical.
They're astronomical, yeah. So that's always been my sense of the answer to Fermi's paradox. Where is everybody? Given those numbers you just rattle off and the 100 billion or trillion galaxies in the known universe, surely there's life somewhere else. Okay. But the chance of them coming here, it just seems astronomically low. It's just so much empty space and vast distances between them.
Who knows? I don't think our technology is good enough, but it sure is getting better all the time. And someday we or our descendants will know, and maybe we will go to other star systems. But right now, we don't have a clue how to do that because we don't have the technology or even anything close.
By which you mean chemical rockets?
Right. Exactly. And even our ion propulsion rockets, which are now common for in-space propulsion, and we're on the verge of developing fusion. I'm actually helping a company that's doing that. They're going to let us go a lot faster, but still to cross the distances between the stars is far beyond our present capability. We'll get there. I think humans will get there, but probably not in the next few decades. It would take some unexpected breakthroughs.
Right. Is DARPA or NASA working on, I don't know, anti-gravity propulsion or gravity propulsion systems or something like this?
Maybe, but I'm not aware of it.
I see.
I'm reminded of what Carl Sagan said. He said it so well, like so many things. Mm-hmm. And back in the 70s, he was talking about advanced technology. And he said, we can't imagine what it will be like in a century or two. And he said, any more than if you told Christopher Columbus that one day 50,000 people would cross the Atlantic every day, he would picture ungodly numbers of wooden ships. And he wouldn't think of airplanes, right? And if you told, let's say, indigenous people in Micronesia that one day there would be communications that would go all around the world instantly, they would picture really big drums. They couldn't picture electromagnetic communication. And we can't picture what may be commonplace 100 or 200 years from now because we don't know what breakthroughs are coming.
Yeah.
Things that look like magic to us won't be magic to our descendants.
Yeah. Yeah, there's that book on super forecasting, and the results show that nobody can make accurate predictions beyond about 5 years of technology, stock market, wars, conflicts, any big movements. Just nobody knows.
Sure. I remember when computers started first coming into the home, that my then mother-in-law said, well, I don't need one because I don't do much math. I don't need a computer around this house. But
right.
Who knew that it was going to be all about social and communication and what we're doing right here and so forth. And that was only 10 years in the future.
Unbelievable. Yeah. All right, bring us up to date on what the New Horizons spacecraft is doing. What's new information since Pluto?
Well, first of all, New Horizons is very healthy. It was launched almost 20 years ago. It'll be 20 years in January. And the spacecraft is in perfect functioning condition. And it has the power and the fuel to fly to mid-century, to 2050. And this is a testament to American workmanship and engineering design capability in this country, and to the men and women who worked on this to design it and build it and test it and get it launched. We flew by Pluto in 2015. No spacecraft had ever been there. Farthest flyby of a planet ever. Then we went on into this third region of the solar system, even farther out, called Kuiper Belt. And in 2019, we made the first exploration up close of a Kuiper Belt object. These are the seeds or building blocks of planets, and really ancient thing from 4 billion years ago. We got a close-up look. We hunted it down in the dark and flew right over it and returned a lot of data. And we're now looking to fly by another one, if we can find one within our fuel capability to get to, before we leave the Kuiper Belt in the early 2030s. At the same time, our spacecraft is doing what the Voyagers did when they were very far out from the sun like we are. We're more than twice as far as Pluto now. They're exploring the outer reaches of the sun's domain called the heliosphere. And we're getting ready to cross into interstellar space, just like the Voyagers did, but with much more sophisticated instrumentation than the Voyagers, because they were built, technologically in the Stone Age. They were built in the 70s.
Yes.
Right? And we have 21st century technology. This spacecraft was designed in the early 2000s, built in the early 2000s. And so we have much better sensing capability to study in more detail and in new ways what Voyager couldn't, and to do this Kuiper Belt exploration. So everything's looking good, except for the fact that the administration has proposed to cancel New Horizons effective in October, and to cancel dozens of other perfectly working spacecraft that NASA has. And I find it heartbreaking. The United States taxpayers paid tens of billions of dollars to put these assets in space, and we lead the world. And if that budget proposal goes through, I believe the number is 55 perfectly working missions around the solar system, around the Earth, even at the moon. They'll all be turned off in the next year. Not to make very much savings. But the unfortunate fact is the United States will voluntarily go from first place to fourth in space exploration overnight by turning off all these working spacecraft. And I think, and I'm a budget hawk myself, even when I was at NASA, some people didn't like that I was a budget hawk and I didn't want to stand for overruns. This is not that. This is not about overrunning missions and misperforming. This is about I think lower level people who the president probably has no idea are getting ready to cede our leadership in space to the Europeans, the Japanese, and the Chinese. And I hope that the administration gets word. I hope that people will write the administration and write Congress too and tell them, don't screw with my NASA. That's a sign of U.S. leadership, soft power projecting.
Yeah.
We paid for all these spacecraft. Why are we turning them off?
What does it mean to turn them off? I mean, they're still out there beeping away. Is it just the people monitoring it are no longer working there? They just shut off their computers?
Well, you do fire all the people and you terminate all the contracts, but also by NASA rule and regulation, we have to free up. When we turn spacecraft off, we literally send a suicide command. Turns it off forever. And then they cannot be turned back on because their radio receivers are turned off. They can't hear us say, oh, we changed our mind 2 years from now.
Oh my God.
Okay? That's it. Because NASA wants to make sure when spacecraft die sometimes, or they get sick, they get old, or they don't perform correctly, or sometimes even they've done their purpose and they're finished. And then NASA will want to clear that frequency that spacecraft is using. They turn the spacecraft off. And that's the right thing to do when you get to the end of a mission, or when you get to, malfunction situation, something like that. This is not that. This is working spacecraft that have been peer reviewed, and, the science is very good. And we're just going to summarily turn 55 of them off within a matter of 100 days, starting this fall, if this goes through.
Why?
And I don't understand the logic. And as a patriot, I think the president and the Congress have to stop this. And I think it's lower level people who are probably thinking they're doing something good and saving money, but it's completely upside down to pay tens of billions of dollars to put all these spacecraft out there, and when they're working, to turn them off. And I hope that people who are listening to your podcast will write their congressman and, frankly, write the president. I don't think he has a clue. I don't think that most people in Congress have a clue that we are literally about to walk off a cliff and cede the leadership of space exploration to the Chinese.
Well,
And it's going
Trump,
to happen this year.
that's unbelievable.
We're in
Yeah,
September.
we got to get a write-in program going. We'll do that. We'll help you with that. I mean, Trump is a big, make America great. We are number one. Okay, so why would you give that up? And he just announced moving the space, whatever it is, Space
Space
Force
Force
to
to
Alabama. So obviously he's into space.
Well, and the president was very supportive in his first administration, as many presidents have been, but he was particularly supportive of NASA. He appointed Jim Bridenstine, was a great administrator. Lots of new things got started in his first administration. He, in his inaugural speech, talked a lot about, he talked a lot compared to most inaugural speeches, and in his State of the Union also about our leadership in space. We need to lead in human space flight. Lunar exploration with astronauts. We need to make sure the Chinese don't own the moon, the resources there. We need to be first to Mars for a lot of reasons. But we also need to maintain our leadership in science and the soft power projection, because, terms like Voyager and Hubble are in every textbook in every language around the world. And little kids, even in nations that can't stand us, their children learn about Voyager. And they learn about Apollo, and they learn about the Hubble, and that's soft power projection for the United States. That's the United States leading the world, not just going down in the textbooks for developing new knowledge, but it's our brand. NASA is really, I think, at the core of how America thinks of itself as a leader heading towards that Star Trek future. Well, we can't go off this cliff this way.
And these underlings, was this part of the Doge movement to cut government
the
expenses?
ideas came from. I don't know. I do know it's in the president's budget, meaning the administration's budget proposal called the PBR, or President's Budget Request, and Congress is grappling with that right now. And I think there are also a lot of good things in what they're planning for NASA, and there are some important changes that needed to be made. So this is not uniformly bad, but this idea of turning off all these working spacecraft that are out there exploring, and the cost of it is about 1 penny on the dollar. It's not like it's really saving a tremendous amount of money, even in the scheme of a NASA budget that's relatively small. It's at the margin, and yet we're just going to go to fourth place like that.
Well, that's the angle. China is going to take us over in space exploration. Trump would not like that. Not one bit.
My belief is that most Americans and probably a lot of MAGA Americans want us to be first.
Yeah,
that's what making America great again is. It's not about it voluntarily dropping to fourth place in technology and in space exploration. That's at the core of how we see ourselves as leaders, and this is a message that I hope people will get upset about and write their politicians and write the administration. Do you realize what a mistake this is? There are plenty of other ways that we can go about saving money and making NASA more efficient. There's always plenty of room for that with any government agency. But summarily executing 55 working missions isn't.
That's just nuts. That's crazy. I mean, it's one thing to cut a program that hasn't, really taken off yet, and it's not going to happen for 20 years. All right.
So if you can tell, it's like that old movie Network, I'm saying I'm mad as hell and I'm not going to take it anymore.
Right.
That's what I'm telling you.
Let's do that. Yeah, absolutely. So how fast is the New Horizons spacecraft going?
Really fast.
I mean, like 100,000 miles an hour?
Not that fast.
Okay.
But it's going 35,000 miles an hour, which is twice the speed of a space shuttle.
Yeah.
And it's crossing about the distance from the Earth to the asteroid belt every year. It gets further and further and further out. And it's the fastest spacecraft ever launched. Let me give you an idea of how fast this is. When I was a boy, Apollo missions launched to the moon, 25,000 miles an hour, and it took those astronauts 3 days to reach the moon. Every one of the Apollo missions, 3 days. New Horizons launched at 2 p.m. in the afternoon on Thursday, the 19th of January, 2006, and reached the orbit of the moon not 3 days later, 9 hours later.
Oh my God.
Basically 0.3 days.
Wow.
And it still continues with almost that exact same speed because we got a boost from Jupiter
Hmm.
to this day. And as I said, fastest spacecraft that's ever been launched. Nobody's ever topped it.
If Apollo's going 25,000 miles an hour to the moon and the moon is 250,000 miles away, why does it take 3 days?
Because the Earth's gravity slows the spacecraft down. It's 25,000 miles an hour for a moment. But within an hour or two, it's way slowed down by that tug of the Earth's gravity. And when it gets out of the gravity, the Apollo astronauts crossed over to the moon's gravity at a speed of only 3,000 miles an hour.
Okay, that makes sense.
Right? Yeah.
Yeah, that's amazing. Well, so, and what is the status of NASA's plan to get back on the moon?
Well, that's called Artemis.
Yeah.
And that's a very ambitious plan, not just to put us back on the moon, but to have multiple flight providers that can do that. So it's as if you're buying Chevys and a couple of other brands to make sure that you'll always have reliable transportation. And then to establish a permanent presence on the moon near the South Pole. What's important there is that's where we know that the water ice is. And the water ice is a resource, can be used for many things. It's important scientifically, but it's even more important because you can break up the water molecules. You can use that ice for breathing oxygen, for rocket. Hydrogen from the water goes as rocket propellant. And there are many other applications like cooling systems where the water, it's a super resource. And we don't want to have to carry it to the moon, haul it over there if it's there for the taking, so to speak, if it can be used. And there are literally, I believe, trillions of tons of water at the lunar South Pole. So putting up an Antarctic-style base, a small one with a handful of people, it'll probably grow. But initially, and using that water as a resource would make the base much less expensive to operate and easier to maintain. And the Chinese know that. They're doing the same thing. They're also going for the South Pole because that's where the water is. And NASA has now developed the rocket to do this. They have developed the capsule to do this. They've contracted SpaceX and also Blue Origin to provide landers, human landers. They don't look like the old Apollo ones. They're actually much bigger. They can carry more people, and they're reusable, unlike the Apollo. And NASA hopes to launch the first crew to go out just to orbit near the moon and come back next year on this new big rocket. And with this capsule that looks a lot like the old Apollo capsule, but it's much more sophisticated because it was built with 50 years later technology. That's called the Artemis program. The landers are going to come a little bit later. And in fact, the big Starship rocket that SpaceX is developing is one of the selected systems for this, but there are others. Given another 4 or 5 years, NASA will probably have humans back on the moon, but the Chinese are trying to beat us there. And they might beat us. Personally, I don't think that would be the end of the world. Because after all, if the Chinese landed next Thursday and I were president of the United States, not that I ever would be, but if I were president, I would say, well, welcome to 1969.
That's right.
We did that before any of you were born.
And the flags are still there, even if they're bleached.
And now we're playing a different game. We're coming to build Antarctic-style bases, and we're not in a race with you. But a lot of people think we are in a race with the Chinese, and maybe they're ahead. I don't know enough to know. I hear a lot in the press that they might be ahead of us. I don't know why we let it be a competition, because we want to do something of bigger importance. That is, build a permanent outpost there.
Yeah.
And I'm sure that we will do that. In 10 years from now, children will walk out in the yard with their parents, and the parents will point up at the new moon, and they'll see a little light burning near the South Pole of the moon and go, that's where people live.
Wow. Could you see that with telescopes from Earth?
Probably even binoculars if we do it right.
Really?
Hell,
Wow.
If I were running NASA these days, I'd make sure we put a searchlight up there so everybody in the world could see that, and I'd make it flash red, white, and blue.
Put a big logo on it.
Why not?
Yeah. What about Mars? Do you think we could do everything you just described, but I don't know, in a half
Mars
a
is a lot
century?
harder,
Yeah.
but we can do this, and as a nation, and even private industry. It might be that SpaceX or others that we haven't thought of yet are exploring Mars with humans in the 30s and 40s. Private industry. We'll have to see, but we have that capability. I don't mean we worked out every detail, but it's not beyond us to do these things.
Yeah.
And it is the future. And I think that it's going to be very inspiring. And after all, the, the entire economy of the United States depends upon technology.
Yeah.
Everything we do, all the important industries, um, even agriculture, depend upon technology. We have to train kids to go into science and to go into engineering. Those are hard fields. There's a lot of math involved, right? And we want to inspire kids to go into these STEM careers and tech careers and to put up with all the math education they have to do because these are hard things. And space exploration, my terminology is it's the gateway drug to a tech career. Space
Right.
exploration enthuses children, gets them hooked on engineering and science. And that is, in my view, the biggest intangible benefit, but a real benefit is that it powers the economy. And if you talk to tech billionaires, you ask Bill Gates, he's been asked this question, or you ask Steve Jobs when he was alive, ask that question, or ask many of the others and say, what really, what was it like when you were a kid? I want to grow up and be an astronaut. I want to go into space exploration. They ended up in something else.
Mm-hmm.
Most of those kids that wanted to start off to be in the space industry, they might not have been as hard-headed as me and my cohort. Those of us that do that, they end up being electrical engineers and computer scientists, and they're inventing AI and the internet, and they're inventing affordable PCs and everything else, electric vehicles that we have. We need more engineers. We need more scientists, and we need them to be enthusiastic through all those math courses and the physics and the chemistry. I took all that. It's hard stuff for most people. And you got to, your business major friends are having a much easier time. They got less homework, and they're looking at, a very successful career path that can make some money. Engineers, scientists, not so much, not as rewarding to a lot of people. That's why I think space exploration is important. Beyond its own value is the inspiration it provides to children to go into these STEM careers. And we need that, or we're not going to have an economy in 30 years.
Mm-hmm.
Somebody else is going to be doing all that somewhere else on this planet.
Mm-hmm. Why didn't we do all this after Apollo? Back to your previous identification of a problem about to happen. It's just political, right? It was politics.
There was a lot of backlash against the Vietnam War, what was called the military industrial complex, and NASA was caught up in a lot of that. There was a lot of interest in solving problems of poverty and injustice at that time. And I was only a child, so the adults were listening to the news and I only heard blips and so forth. But there was kind of a revulsion, and both the Defense Department and Defense Enterprise and NASA and other tech projects like the American Supersonic Transport, they went by the wayside for a long time until in the 80s, kind of tech was reborn. And it's unfortunate because we lost a lot of ground, but that's what actually happened. And here we are. We have an opportunity to not make that mistake again.
Yeah.
And instead hit the accelerator and really advance the standard of living, which technology has done tremendously, and to advance the economy, which tech powers a lot of that, maybe most of that. And space exploration is going to be a big part of it, but also it's got that pair of intangibles, two really wonderful things. It inspires kids to go into tech fields, go through college and study that stuff, and it's soft power projection around the world that the United States is a leader, and a leader at peaceful pursuits. And I think that's very important.
Again, that's right up Trump's alley. He could make that happen. He could just pick up the phone and make sure that these spacecraft are not turned off. Yeah, here's what we should do.
And they would turn on a dime, wouldn't they?
Yeah, absolutely.
He's the president of the United States.
He's
right?
The commander-in-chief.
You see presidents all the time, past presidents, say, I learned something I didn't know that's going on that I'm going to go fix. And so this isn't so unusual. And I think he probably has no clue of what's about to happen. The problem is once these spacecraft get commanded off, there's no turning them back on. That's
Right.
it. Done.
I think a lot of people don't know this. I didn't know it. So in addition to releasing this podcast, we should release an article from you on skeptic.com. We'll push that out on our social media and all our different platforms and just have a list of everybody you can write, all the congressmen. It's just, those are available online. Who should I write to complain? Right there. Okay.
Right.
We
You're
should
right.
do
The
that.
people on the appropriations committees, and you're right. The president of the United States.
Yeah.
Don't start any lower. Start right at the top.
Right at the top. Okay.
Right? Don't let it
All right.
filter up through the bureaucracy. Start at the top. Write the president. Tell him I'm mad as hell and I'm not going to take it anymore. This one is a mistake. You probably don't even know what's going on, or you wouldn't have let it happen.
Right. All right. We'll make this our mission. That sounds good, Alan. All right. Before I let you go, just a couple quick lightning round questions here. Your thoughts on the search for biosignatures, technosignatures, the SETI program, all these different search for life elsewhere.
We got to do that stuff, don't we? Everybody wants to know. And it's a hard problem on every level. And because our technology is probably primitive, compared to whatever might be out there, we might not even have the technology developed yet to tell who they are. I mean, after all, the ants in Manhattan don't know they're in the middle of this super civilization, do they?
That's right.
We might be just as aware. Who knows? But we have to find out. It's what makes us human. And I think we're starting to develop the tools now to really be able to make progress on this for the first time. And it doesn't cost very much. The total amount of effort spent on these pursuits is like the equivalent of a few dozen McDonald's restaurant staff. It's nothing. It's nothing. And yet the potential for it is so amazing. I think we have to do it.
And what is the James Webb telescope been discovering that's changing our understanding of the cosmos and its evolution?
James Webb is very expensive. And I think it didn't need to be that expensive. But it turns out to be an amazing piece of machinery and the best tool anybody's ever launched into space for studying the universe. It's making discoveries in every nook and cranny of astronomy and planetary science. It sees things we could never see before. And I don't just mean the resolution, but its sensitivity, its ability to look at fainter things so we can study more things farther away, and its ability to study the composition of planets and moons and other things in our solar system is unparalleled. Its ability to look into the hearts of black holes and the evolution of galaxies, the origin of the cosmos, it's just unbelievable. And it's very productive. It's now, it was launched in late 2021. So it's going on 4 years. I think they've really got it down to a good pace now. It's very productive. They're using it. It looks like it's going to last 10 or 15 or maybe longer. And we need to milk it for all it's worth. It's the best tool anybody's ever launched.
Didn't I see something about it discovering galaxies very early in the age of the universe that should not have been that well formed?
Right. And so by being able to look at fainter things and farther things and look better than ever before, we're finding out a lot of our ideas, even with the Hubble, this thing's so much better than the Hubble in many respects that it's teaching us all new stuff. And a lot of our ideas are now looking a little dated because we have this much better tool. It's like, if you used to look at the moon and draw pictures naked eye, and then you develop binoculars and it's just a whole new world. And that's kind of the equivalent of James Webb is like putting on the binoculars for the first time.
Yeah.
So I have to say, it is probably the most important astronomical tool ever launched.
Wow.
It cost a lot of money to build it, but no one is in a position of catching us on that one. And by the way, that one is not scheduled to be turned off.
Oh, thank God.
It's just that all the others practically are.
Yeah. It's like you read the history of astronomy, and they didn't start putting telescopes on mountaintops until like the late 19th, early 20th century. Just so obvious. I mean, you read about some of these early ones, they're just out in the cornfield somewhere and flatland nowhere.
Yeah, well, hindsight's a wonderful thing, isn't it?
Yeah.
Once we figured out how to do that, right?
Wouldn't you love to be cryonically frozen and come back like 500 years from now and find out, oh, this is the explanation for dark matter. Now it's obvious. or whatever.
That would be pretty interesting, wouldn't it? But I'd worry about being like Woody Allen in Sleeper.
Oh yes, right. Come back or Idiocracy. Come
Yeah,
back.
one of those.
Everybody's decline of intelligence of
Better, I think, would
humanity.
be to just live the whole 500 years if medicine could get us to where lifespans were much longer. People could be more productive for more years and be better stewards of the planet and be better stewards of one another and raise their families for transmit their wisdom, not just as grandparents, but great grandparents, and in good health like you are. But imagine if your health at age 250, how productive humans would be. Think
Okay,
about
I'll
that.
go for that.
Why have to wake up in 500 years if you can experience the whole 500 years?
Yeah, right. Yeah, exactly. Yeah. All right, last question. What is the fascination people have with the idea of extraterrestrial intelligences and aliens and UFOs and all this? I mean, just people just lose their minds in excitement over it.
What I would like to ask what you think it is.
Well, I think it's like a
What are you
religious impulse. I do. I've written about this, deities for atheists. I think it is a form of, just kind of trying to put ourselves into perspective of the cosmos. And that's really what religions ultimately do. What's our place in space and time? Why are we here? Where did it all come from? The biggest questions of all that religions have had a monopoly on answering. And now science can give us an answer that's testable. I mean, this is an original me. This is a point Sagan made a long time ago, that there's something religious behind it. Not that religious people have more interest or less or whatever. It's just that all of us have an interest in this, and that's what fuels religion. And now it's science. I mean, I see this mentioned Avi Loeb and the Galileo Project. I mean, he has TV crews in his office pretty much every day. It's just because he says, hey, it could be aliens. Let's think about that. And no, he's not a UFO nut or anything like that. But, people just, the moment you say, hey, this could be it. Wow. Okay. You've just made the case. It's probably not it.
I don't think you're wrong. I think you're onto something. I would say also, in my mind, the other thing is none of us like to be lonely. Humans are social creatures. And I think as a society, as a species, we want to know if we're alone in the universe or not. And,
Yeah.
I think a lot of people would like to think that, that the universe is teeming with civilizations and that we're just, kind of getting to graduation level where we can start to be a part of that community. But we don't know if there are any, if it's a real thing or if we're somehow, the only ones. And that's a very deep, very powerful question that inspires people. And someday we'll know. But until we go out like the way Avi, I have to give him credit for being a very forward thinker, even though he can be controversial. He's a
Yeah.
brilliant guy,
Yeah.
and he inspires people, and he is working on it every day. We need more people like that.
He just emailed me. I was just approached by 2 race car drivers who wish to feature my image on their car in NASCAR because of 3-Eye Atlas. That's
Have you
crazy.
bought a race car? I'm all for it. Why not?
How about that? A science geek on the side of a race car. That's
There you
pretty
go.
cool.
Harvard professor on a race car.
What about that Kardashev scale of civilizations? Do you think that's a good heuristic to think about?
I think
Yeah.
Kardashev and Sagan popularized it.
Yeah.
I think that's one interesting way of looking at things.
Energy
And
consumption,
the
right?
most important thing about it is it's these big steps of factors of 10. And,
Yeah.
we used to have campfires and now we have nuclear power plants. And we used to
Right.
have, bows and arrows. And now we have, Starship rockets and Saturn V's and Space Launch System. And the technology just keeps growing. And we are orders of magnitude from where we were just a couple of centuries ago. And in a couple more centuries, we'll be so far in the future that Star Trek may look antiquated. I'm an optimist. I
Well,
think
they did have flip
for humans
phones.
to invent and to discover, and that it's our destiny. We are unlike any other species on the planet in being curious and
Mhm.
having interest in building tools and technology and asking questions like this. It makes us very special. I don't know how we got so lucky, but we are for all of our faults, um, very special species with lots and lots of promise. And I'm very
Mm-hmm.
optimistic about the future, even on days when you read the news and it's all bad. I still think, look at the big picture over the last 1,000 years, how much better things have gotten for humans. And I
Mm-hmm.
think we're going to continue on that path. Hope so.
Yeah, it was one of my favorite books is David Deutsch's The Beginning of Infinity. You know, that all problems that are solvable as long as they don't violate any laws of nature, we could do anything. So to the stars, what is it? Ad astra per aspera, to the stars with difficulty.
There you go. It's the
That was in
Kansas
one of
State
those.
Law.
Yeah. All right, Alan. Thanks so much. We're gonna talk offline here about getting an article in Skeptic and release that and this podcast and get people to write their local politicians, senators, write the president.
There you go. Thank you, Michael.
Make
It's been a
America
blast.
great in space again. We
Let's
already
do it.
are. All right.
Let's do it.